Welcome back, Blockchain from Scratch, part number 5. Today we're going to implement the block. Our block consists of a few different data structures. So the first one that we're going to talk about is the block header, and the block header contains the most important information about a block. So it contains the root, and this is the root of the Merkle tree of transactions that we built in 03, the previous hash of the previous block, and each block links to the previous one. It also contains the block number, the number of transactions that are included in the block, a Boolean flag, mined, and of course the time of creation. So we're going to create this header, and this header is of course inheriting from the hashable class. So we inherit all the properties from hashable. So if we create a block header with some random data, it looks like this. And of course, if we change something in the block, its hash should change as well. So here we're going to copy the block header into block header changed. We're going to change the number of this block header changed to 120. And of course, our block header number is actually 2. And then we're going to compare if the block header is not equal to block header changed. And this is the case. So if we don't change anything in the block header at all, this should fail, right? Because we didn't change anything. And this block header is what we're going to use for mining. So the actual mining will happen on the block header, not the block itself. So then we also create a info class, and the info contains all the information that are not as important as the information that we're going to include in the block header, but some interesting facts about the block, but information that we don't need for mining. So what we're going to calculate here is the volume of transaction values in the block and the sum of all the fees that are paid in each transaction. And now we can create our block. So our block is of course hashable as well. It takes in a block header and a list of transactions. We're going to create a new info object from all the transactions. So we're going to calculate the volume and the fees. We're going to set the block header. We're going to calculate a full Merkle tree from our transactions. And then we're going to set the transactions. But before we do that, we validate all the transactions. So validate transactions, of course, takes in all the transactions. We're going to check for the signature. So valsig is something that we implemented in 04 wallet, and we're going to check if the block only includes unique transactions. So we don't want to include any duplicates. Then we're going to check if the Merkle tree root that we calculated from all the transactions is equal to the root of the block header. And we do that to ensure that the block header transaction Merkle tree root is actually the correct one. And then we're going to return all the transactions in a dictionary. So in this case, the transaction hash is the key, and the transaction object itself is the value. For our API, we're going to implement a JSON method as well, and this JSON method will just return our block as a JSON string. We also define this $getItem method, and this will actually allow us to get a specific transaction from the block using its transaction hash. And then, of course, in the end, a method for printing it out. So what we're going to do now is define this random signed transaction method, which will just generate some random signed transaction for us. And then we actually can create a block. So first, we're going to create 4 random signed transactions. We're going to create a Merkle tree, and then we can define a block header, and a block header takes in the root of the Merkle tree, the hash of the previous block. In this case, we're just gonna generate a random hash, the number of the block, and the number of transactions. And then we can create our block in the end, which just takes in the block header and the transactions. And then if we print that out, we're gonna get all the information that is included in the block and the transactions as well. Then for our API, we also need to implement a load block method, which takes in a JSON string of a block. So that's what we're doing here. b.json will generate a JSON string, and load block will take that in and return an actual block object. So if we do that and print this out, this is the block object. And then we want to assert that the actual block that we defined here is equal to the one that we load from the JSON. And this runs as well. Then we also have the ability to access a specific transaction from the block. So here we're going to get a transaction hash, and then we can access the transaction by providing this transaction hash to the block and returning the corresponding transaction object. So what we're going to check for next is that our implementation only allows unique transactions in the block. So here we're going to copy transaction 1 to transaction 0, and then we're going to create a new block header with this duplicated transaction, and what we want is that this fails. So we want to detect a duplication, and so we're going to try to create this block, but this should fail. So duplicate detected should be true, and then we're going to assert that duplicate detected is actually true, and this runs as well. So the block data structure that we built here is basically just a data object that holds some information about the block and some very basic validation, right? So validate signature, and we're going to check if the transactions are unique, and we're going to check if the Merkle tree is correct. So that was the block. In the next one, we're going to talk about mining in 06. So see you in the next one. Bye bye.